Hi everyone. The goal of this video is to learn all about logarithms. So the first question we need to answer is, what is a logarithm, or more commonly referred to as a log? Now, in order to answer this, let's talk about some things we've been learning about. Let's take a look at the equation y equals 3 to the x, which should be a familiar exponential equation that you've seen. In order to find the inverse of this, you would switch the x and the y. So you'd get x equals 3 to the y. And in order to get the actual inverse equation, we'd have to solve for y. But once you get to this point, everyone should be thinking, how the heck do I solve this equation for y? How do I undo that 3? What's the inverse of an exponential equation? And the answer is the inverse of an exponential equation or function is a log. So they're operations that undo each other. The inputs of one would be the outputs of another. Like addition undoes subtraction. Log will undo an exponential and vice versa. Okay, so to be more specific, if I have y equals 3 to the x, the inverse function would be y equals log 3 of x. Okay, now let's go into this a little bit more deep. In order to do that, I'm going to write this with all variables instead of using that example here. So let's write that off to the side here. So let's say the exponential equation, b to the y equals x. Okay, so b for base to the y power, the output is x. That's equivalent to y equals log base b of x. Okay, so if you think about this, what is a log solving for? So if this is the function, the output is y. Okay, now if you take a look at this, y was the exponents. Therefore, all logs solve for exponents. And this will make more sense with a few examples. Okay, so just to make that a little bit more clear before we go to the examples, these two forms are equivalent. So if b is the base of my exponent, b is like the little number on that log, and we actually also call this the base of the log. Okay, the base of the log is b, the base of the exponent is b. So my general thumb is the base of the log becomes the base of the exponent, or the base of the exponent becomes the base of the log. And if logs solve for exponents, that means the output is the exponent. See, output is the exponent. Okay, so if you use those facts, we can rewrite any log in exponential form. For example, log base 5 of 1. What I said before is that the base of the log becomes the base of the exponent. Okay, the output of a log is the exponent, which I don't know the output of this log, that's what I'm trying to find. So the exponent right now is a question mark. But maybe instead of writing a question mark, I should call this, I don't know, the output's usually y, so maybe I'll call it y. Now, this is called the argument of the log. That one is the argument. That's always the output of your exponential function. So the question that I'm really asking when I'm asking log base 5 of 1, that's how you'd say that, log base 5 of 1, is 5 to what power equals 1? Because all logs solve for an exponent. Okay, so 5 to what power equals 1? And the answer, or the only logical answer, is that y would have to equal 0. Because anything to the 0 power is 1. So that means if I asked you to evaluate or simplify log base 5 of 1, you would tell me the answer was 0. Okay? So we can do a bunch of examples like this. I'm going to give you multiple examples to try on your own. So you can try this one and this one. And I'm going to go ahead and do this one. The reason I'm going to do this one is because there's no number there where the base is. And that's because this is the common log, or the standard log, and the common log, the base is always 10. So think like scientific notation, base 10, standard base is always just 10. So if you ever see a log without a base, you can assume this is base 10. So this is really saying log 10 of 1,000. Which if I want to evaluate this, I'll write this in exponential form. So the base of the log becomes the base of the exponent. A log solves for an exponent. So I'm trying to find this exponent. So it's really saying 10 to what power equals 1,000. And if you think about it, this fact here makes sense. A log solves for an exponent. And that makes sense because the input into an exponential is an exponent. So that means the input of the exponential should be the output of its inverse. So the output of a log is the exponent. Inputs and outputs have switched. Anyways, 10 to what power is 1,000? The answer to that would be 3. So it would be 10 to the third equals 1,000. So that means log, or the common log, the standard log, base 10 log of 1,000 equals 3. So that's how you'd evaluate that. Okay, another thing that might look a little bit less familiar is this ln thing over here. This is called the natural log. Natural log. And the natural log is really just log base e. So remember, e was that number we talked, which again is about 2.7182818, yada, yada, yada. Okay, so really what this is saying is log e of e squared. So to evaluate this, again, you would go ahead and rewrite this in exponential form. So the base of the log becomes the base of the exponent. Okay, the log is going to solve for what the exponent is. So the output is the exponent. Maybe I'll make that a y. So e to the y. Now the argument here has an exponent. That's okay. This whole thing's the argument because you're taking the log of that whole thing. Right there. So e to the y equals e squared. In order for these to be equal, what would y need to be? The answer is y would have to be 2. So if you think about that, what happens when you take a natural log, which is log base e of e? Really what happens is those cancel each other out and you're just left with the 2. Okay, I leave that one for you to try. It's a challenging one. See what you can do. Okay, one other case you might see is some log equations. Essentially the same idea where you want to rewrite into exponential form, or if you have an exponential form, maybe you want to write log. I don't know. It's up to you. Depends on the problem. Okay, so the base of log becomes the base of the exponent. So the exponent base is 3. The output of a log is the exponent. So 5 is now the exponent. So really that equation is saying 3 to the 5th equals x, which you can multiply 3 5 times and figure that out. Equation could be a little bit more complicated, like one of these. Remember, this is log base 10 if it's not written. So it's really saying, okay, 10 is my base, so it's the base of my exponent. My output is my exponent. So it's saying 10 to the 1,000 equals my argument, which is x plus 3. So you can evaluate that, subtract 3 to get the answer. Now you may also see some exponential equations, which in this one you could probably just guess, which I'll let you do that. But in this one, for example, you might have to do some solving. Because really, what I'm trying to figure out is, well, actually I guess you could guess on this one too. So 2 to what power is 64, and you could do a little guess and check over. I happen to know that 2 to the 6 is 64. So that would mean x plus 1 had to equal 6, right? So if x plus 1 equals 6, then in order for that to happen, x would have to be 5. Because if you plugged in 5 here, you'd get 5 plus 1 is 6. Okay, so you could do a little guess and check here, but logs give you a more efficient way to solve an equation. Remember what I said, that the log is an inverse of an exponential. So just like if you had x plus 3 equals 7, in order to undo 3, you'd subtract 3. In order to do an exponential, or the base of the exponential, you'd have to take the same log of both sides. So in order to undo this, I'd have to take a log base 2 of both sides. So really your equation would say log base 2 of 2 to the x plus 1 equals log base 2 of 64. Okay. Now the reason that, there's my base 2. The reason that this works is kind of like what I said over here. Remember, those bases wind up canceling each other out and you're just left with 2. They're inverses, so they should cancel each other out. So log base 2 of 2 cancels and you're left with just x plus 1 equals log 2 of 64. Which log 2 of 64, we can use our log skills to evaluate that and get some number. So remember, this is 2 to what power equals 64, which I said 2 to the 6th equals 64. So that would have to be x plus 1 equals 6, question mark, equals 6, which you wind up getting the same thing as if you thought about it, but just another way to do it. So if I wanted to undo e to the t, I'd have to take log base e, which we call natural log, of both sides. Okay, so that's a lot of information, a little bit of time. I'm leaving a bunch of equations blank for you to practice and think about, what you know and understand, what you still have questions on, what you might like to practice as a class or on your own with your groups. So please come with questions and have a great night.